In this video, I want to talk about one of a SAT math example, and this is about simplifying a advanced rational expressions. And the question is, which is equivalent with the following expression? 3 over x squared plus 5x minus 24, all of them minus 7 over x minus 3. And if you look at this fraction carefully, it is obviously formed as numerator and denominator, and both numerators are the natural numbers, and one of their denominator is formed by a quadratic one. One of them is formed by a nominal one. So using this pattern, I made one solution for this pattern. It is formed with step 1 and step 2. For step 1, we knew that it is a fraction, so we need to simplify, which means we need to have a reduction, unless it is x multiply or divide. And then we go to step 2, leave all the numerators, and for the quadratic one right over here that I'm pointing out, we need to convert it into binomial. The reason is because we need to simplify easily with a binomial one and carry about some nominals one in order to have a common denominator to simplify. So at first we need to factor this out into a binomial one, and since we knew that it is a quadratic one, after we saw a biggest exponent in this equation is 2, we can simplify. So I'll write this down here. X squared plus 5x minus 24. According to a binomial theorem, at first, x times x will going to give us x squared because there is no constant except for 1. And then for this number, for these two numbers, if we add it together, we will get a positive 5x. If we multiply together, it will going to give us negative 24, which means one of their numbers should be negative, but the bigger number should be the positive. So we need to think about some factors of 24. Let's think about 1 times 24. Well, 1 times 24, if one of their sign is negative, I said that the bigger number should be a positive, which means the smaller number should be the negative. If we multiply together, it shows us negative 24, but it doesn't satisfy if we add it together. It will going to give us positive 5x. It is way too far away. Let's look at the second one, which is negative 2 comma 12. And for negative 2 times 12 is satisfied with the negative 24, but if you add it together, it is still far away with the 5x. And let's go to the next one, which means negative 3 comma 8. When you add it together, it's satisfied with the positive 5x, and if you multiply together, we're going to get us negative 24. So we can say that our factor that I need to input in these values, we're going to be negative 3 and then positive 8. Rest of them, we can cancel this out. So negative 3 and the positive 8. So if I write these equations down again, right over here, we can write it in this way. 3 over x squared plus 5x minus 24. But instead of x squared plus 5x minus 24, we know the value of it when we expand it into a binomial one, which we're going to give us x minus 3 times x plus 8. So x minus 3 times x plus 8. And then minus, in the numerator 7, so 7 over in the denominator x minus 3. And in order to simplify, here comes our diffraction property. If there is a fraction, a over b plus c over d. In order to cancel this out, in order to simplify, we need to have a common denominator by multiplying both denominators together. And in the numerator, it will going to be a But since we multiply d in the numerator and d in the denominator, we also need to multiply d in the numerator, so that if we cancel out both the numerator and denominator, we get the original fraction. Also here we have c, but since we multiply b in the denominator, we also need to multiply b in the numerator. So we can just think about this in this way. For the binomial one, we can multiply every single term from the binomial factor one except for a common one. And this is the main intention why we convert quadratic one into binomial. First reason is because we need to split it and compare what is common and what is not common in order to make a common denominator. Second is because if you just make it into quadratic, it is hard to convert it. It's hard to find the value for x minus 3. What times something makes x squared plus 5x minus 24. So here we need to multiply the x plus 8, because since we knew that x plus x minus 3 was a common one. So if you multiply x plus 8 in the denominator, but since we multiply x plus 8 denominator, we also need to multiply x plus 8 in the numerator. And then we don't have to write the same thing, same denominator again, because they already share one. But instead of writing a binomial one, unless they mention about it, we can just extend it into a quadratic one here, which we're gonna be equal to x squared plus 5x. So x squared plus 5x minus 24. And in the numerator, we can just add it together. We bring our 3. And we need to be careful here with the negative or positive sign. But before that, there is a constant number and a bracket. In order to cancel out this parenthesis, we can just use this derivative property, which is 7x times 7 times 8, which we're going to be 7x, and then 56. The reason why I didn't write sign is because we need to be careful and we need to distribute negative sign to the each terms, which we're going to be 3 minus 7x minus 56. And we're not done yet. We can just simplify with the like terms. We need to remember it. And if you simplify with the like terms in the denominator, it will just going to be same because we already factored it. X squared plus 5x minus 24. And in the numerator, at first there is no term that contains x, so we can just write negative 7x. We can just bring it here, negative 7x. And for 3 and a 56, we can just simplify. But negative 56 plus 3, which we're going to give us negative 53. And we're done simplifying it. So here's our answer. And let's look at some choices. At first, the number 1 is negative 4, which is wrong. Negative 7x minus 53. So we can cancel it out. For number 2, it should be negative 7x minus 53, not 7. And for number 3 is the exact term that we simplified, so we can say that it is our solution. And for our solution right over here, for these patterns, we just think about simplifying. For the reduction, it's just about simplifying. And for the step 2, we know that it's a quadratic one. We expand it into binomial. We convert it in order to there are 2 main reasons, because first we need to simplify easier. And for second reason is because we need to compare both numbers from the nominal one and the binomial one, so that we care about the common and the non-common one. So in the next video, I want to talk about more examples of simplifying the rational expression, and advanced one about SAT method problem using these same patterns.